Hey guys, do we really need 720p high definition on a smartphone screen? What are the advantages? What are the disadvantages? That's what we're going to talk about today on the Android Guy Weekly with Joe Levi. All right, let's lay the foundation of this topic with some history. And to do that, we're going to go back to televisions. In fact, really old televisions. You know the ones I'm talking about. They're big, they're clunky, they hiss when you turn them on. They might even be black and white, but they're that big old cathode ray or CRT technology. Yeah, really ugly and low resolution for a few reasons. Okay, the first reason is the number of lines of resolution that screen had. So let's say you've got, say, a 19-inch TV, which back in its day might have been a little on the big side. Smaller screens were more likely to be back in the early 80s and whatnot. And yeah, that's how far back we're going. But TVs, at least in the US, had about 480, depending on who you ask, 486, but about 480, we'll just keep it nice and even for the purpose of this video, about 480 lines of resolution. Now that means that instead of displaying an entire picture, it's displaying a whole bunch of lines that when viewed together make up a picture. And TVs, you might not know this, but TVs have moving pictures on them. It's called sarcasm right there. These pictures move, and to do that you have to update the lines. So one line may have a whole bunch of dots on it that when put together has a picture of a flower. But then a breeze comes along and the flower moves. Well, to convey that moving, you have to update the lines, and to do that we have what's called interlaced lines. So instead of displaying every single line and refreshing them all at the same time so that the whole screen might blink, we only display half at one time. That's what 480i stands for. That's the I, is interlaced. So you're displaying half of the lines at a time, and then you're updating the other half, the other half, the other half, back and forth, and it kind of gives a little bit of blurring, but it means you only have to send half as much information to the screen as you would otherwise. It made for really not sharp images, but hey, it was TV and it was cool, right? Well, now technology has moved on and we don't have the same limitations. In fact, what limitations did we have back then? Well, most of us didn't have cable TV back then or satellite TV back then. It was usually broadcast. And I know a lot of you did, but let's talk broadcast just for a minute because it's very illustrative of the point that I'm trying to make. Instead of having this huge fat pipe, this bandwidth just seemingly unlimited coming through the satellite or a cable connected to the house, you had an antenna on your roof, in your attic, maybe even rabbit ears on top of your TV. Now there's only so many frequencies that you can transmit signals on, whether those are radio or television in this case. And a television signal takes up a specific amount of space in that bandwidth. So you literally can't have a lot of television signals coming through. A dozen maybe, until you start running into technological limitations with distance and whatnot and start overlapping into other things. But that's a ham radio discussion, not a Pocketnow discussion. So we'll leave that for another podcast somewhere else. But what it does illustrate is they did unique and novel things to try and maximize that bandwidth, like interlacing the signal instead of making it progressive. That's what the P stands for in resolutions. Okay, so far, okay. But the resolution wasn't that great. It didn't really matter because we had antennae on our TV that were just sucking in the signal however they could, and the signal wasn't all that great. It was staticky, it had lines in it that were from, the neighbor was running their blender or whatever. Lots of environmental factors that made the signal really kind of distorted, so the screen, the display looked distorted as well. Well, there was another side of that. On the other end, the people who were actually filming these things, these television shows that we were watching, if you go back now and watch them on a really high resolution signal, like Netflix HD or whatnot, you can see, man, the source really wasn't that great either. It was grainy, it had pops, it had all kinds of artifacts built into it that then was being broadcast out to everybody else, and we couldn't tell because the resolution was so low. We didn't know any better at that point. But then something happened. Our screens started to get bigger. People started to get big screen TVs, and these were big TVs, but they still had 480i resolution. Some people had what were called upsamplers to try and make them look better by interpreting them and kind of doing some math in the signal to to imply more lines than there were. Just was kind of weird and whatnot. But we got to a point where the bigger the screen, the worse the picture, and that wasn't any good. So what to do? In the US, we decided, let's go to all digital pictures so that we could go to high definition screens and high definition content. So what is high definition? Well, it's higher than low definition. That's pretty much it. So the first high definition standard, believe it or not, is 480p. Yes, twice as many lines of resolution as 480i, but in the same space, the same layout, the same all that stuff. The Nintendo Wii, for example, with the right hardware, can output 480p signals, and that's the highest it can go. You know, it doesn't really need to. If you just connect it using the stuff that comes in the box, you're getting 480i. But that's higher definition. It's twice as many lines in the same space. So theoretically, you're getting twice the resolution out of it. And in fact, it does take a little bit more overhead to do. I'll get to that in a minute. 720i is the next one. 720 lines interlaced, just like we were used to. That kind of came and went, and I don't see it that often. Then we've got 720p. 720 lines, progressive, so they're all updated all at the same time. 1080i was around for quite a while, and now 1080p seems to be what everybody's standardizing on because we can do it. 720p, really easy to do. You can get a lot more signal through on a 720p signal stream than on a 1080p signal stream, but 1080p works a lot better for much larger screens, like a big screen TV that you'd hang on your wall. So far, we're good. What does that have to do with smartphones and tablets? Why are we even talking about it? So let's take a look. This is the the Nexus S, and it is a smartphone, if you couldn't tell. This is the Galaxy Nexus, which is a little bit bigger, and this is a Samsung Galaxy Tab 7.7. So, all of these have different resolutions, and they're not TVs. They're displays. Now look behind me, I've got a 19-inch computer screen that has a particular resolution. And different screens for computers have different resolutions on them, and really it's kind of a pain. I'm a web developer. I have to write web pages so that they display well on all of these different size screens. And they're all over the place. How many dots are there? How many lines? How many pixels wide? It's a pain in the neck. Think about smartphone apps. If I write an app for this, is it going to look good on this? Because it has different number of dots. Is it going to work on this? It's got different number of dots. So there had to be something done to kind of standardize on what those dots and lines were going to be. That's where we're kind of going to a standard basic display metaphor, if you will. This metaphor is based around one common type of screen. We're not there yet, but we take a look, even just, generation back phone was kind of doing its own thing. But now we've got 720p. This is a 720p high definition screen, just like you'll find on a 720p high definition TV screen or computer monitor. So whatever I write on one screen is going to look exactly the same, smaller, but it's going to look exactly the same on all of those screens. That's great. There are some pros and some cons to that. Okay, so first let's talk about some cons, and we'll wrap up with pros. First of all, this type of screen is easy to make, relatively speaking. This type of screen with 720p is harder because there are more pixels here, there are more lines. So trying to cram them all down into one screen is kind of hard to do, and we really haven't had the technology to do that very well until just recently, but we just couldn't do it before. We're finally to a point where we can, and well, some would argue we may still not be there, because if you look, this screen, this is again the Nexus, is quite a bit bigger than the Nexus S. So the Galaxy Nexus is a much larger device to accommodate that larger screen. Kind of a catch-22, because you don't want to have huge smartphones, because at what point do they become tablets? You want to have a smartphone that's small, that's useful, that you pack around with you. Really, the Galaxy Nexus is right there on the edge. Some people it's too big, some people like me it's just right, other people I guess it might be too small, but it's right there on the edge. We've really got to make them smaller. Now that's the second thing. If I have a 720p TV screen hanging on my wall with a 720p signal and all that stuff, the dots that make that up are the same as the dots that make this up. This is obviously a lot smaller even than this tablet. So if these have exactly the same resolution, which they don't, but let's say they do, if they have the same resolution, stuff on this screen is going to look a lot better, a lot sharper, a lot crisper than stuff on this screen because the pixels are smaller. So that's the first thing. Things look higher resolution when they're smaller than when they're larger. The larger you go, you've got to get more and more pixels, more and more lines, right? Okay. So ebook readers used to be e-ink because they could make those e-ink pixels, if you will, a lot smaller than they can make actual real pixels. So by doing that, they could have a sharper, higher resolution screen. It was a lot slower and was only black and white, not color, but they could do that, and it really lent itself better to book reading because it was higher resolution. It was more like paper. Now we've got 720p screens. We're starting to see that same level of resolution on ebook readers. Now, of course, there's some power implications that we're really not going to talk about, but we're starting to see a shift away from e-ink and over to real LCD screens because of the higher resolution that we can do in the screens. We're making the pixels smaller and smaller. The iPhone with the Retina display is a very good example of that, making those pixels so small that you can hardly even see them with the naked eye. So really kind of cool. Next, we've got standardization. Once I know that my screen is 720p widescreen, I can write content for it, regardless of the actual physical dimensions, and have everything look exactly the same. All right, so now let's talk downsides. One of the biggest downsides to a screen, other than its availability, a high definition screen, is the fact that there are more pixels. Now I know you're saying, whoa, Joe, you just said that that was an upside. It is, huge upside. But it has some baggage with it. One of those things is those screens are harder to make because the smaller you make things, the more difficult it is to make them. If you have a pixel that's 1 inch by 1 inch, relatively easy to make. A pixel that's 1 millimeter by 1 millimeter or smaller, that's hard. Now, with technology and with automation, it's getting easier, but relatively speaking, it's more difficult to do. That's the first thing. Okay? The second thing is the more pixels that you have on a screen, generally, in this case, the bigger the screen is. The bigger the screen, even when we're talking between these two smartphones, there's one, okay? This has a lot bigger screen area. The bigger the screen area, the more power it takes to drive it. The more lighting you need, it just sucks down power faster. So you've got to have a bigger battery or more efficient use of energy to make up for that if you're going to have the same size battery. So battery life, power consumption is a concern. Another concern is the more pixels you have, the more computing power, not electrical power, but computing power you need to drive it all. So for example, let's say you have a screen, put this over here. You've got this screen and you've got this screen. You can essentially fit, 3 of those on there? So you'd think that if I'm doubling my screen size, then all I have to do is double my video processing power, right? No, you have to quadruple it. The reason for that is you have to multiply height by width. So if you've got something that's twice as high and twice as wide, that's 4 times the number of pixels that you have to create content for, you have to process content for, you have to put out on the screen. So your video processing has to be much more powerful as well, which either means you're using the same video processor and it's going to seem slower because it's still taking the same amount of time to render, say, 1,000 pixels. Now if you've got 4,000 pixels, it'll take 4 times as long, in theory. Okay, there's some other stuff in there that would mitigate that a little bit, but generally speaking, it's going to take about 4 times as long. So, hey, now your new big screen device seems 4 times slower than your old one, right? That's not good. So we've got to have a device to drive it that's at least 4 times faster at presenting those pixels out. And you probably are going to have something faster than that, but the point is you've got to upgrade your tech behind it as well as the screen itself. Of course, that means more processing power and more battery power to run the thing. So again, kind of a two-edged sword there. You've got more pixels, it looks nicer, but you've got to have a bigger screen, which takes more power. You've got to have a bigger GPU, which takes more power. So you got to have a bigger battery. You've got to have, stay close to an outlet, something like that. So there's kind of the ups and downs to it. Overall, 720p is fabulous when we're talking smartphones. That, here's my prediction, is the new standard. Everything is going to be a 720p smartphone display. Now, it might take a little while to get there, but that is going to be it. Right now, we're working on these guys, and we still have some differences in display resolutions. We're kind of standardizing on sizes right now, but resolutions are where it comes into play. In fact, if you'll notice, that's kind of long and skinny. It's a 16:9 aspect ratio, so it's letterbox, if you will. This, not so much. You can see there's a little bit of a difference in the sizes there, in the ratios. So we don't really have 720p tablets yet. I think we will. I think that'll probably be the next step. But after that, when we're talking 7-inch versus, right around 5-inch, it makes sense to be the same resolution, 720p. You're not going to lose that much resolution on a tablet over a smartphone when you do that. But when you go to bigger stuff, like a 10-inch tablet, like the Zoom, like the iPad, that's where you really need to have 1080p resolution to have that same sharpness and clarity. So when will we see that? I don't know. When are we going to see letterbox tablets? I don't know, but it's coming. And it's coming before too long. Give it a year or two at tops, and we'll be able to see kind of where things are going. So 720p, pros, cons, benefits, disadvantages. What do you think? This is your part of the program where you comment on what we've said here. Now, realize that we've kind of dumbed down some of the technical lingo so that we can reach a broader audience, like the whole 480, 486 thing with TVs. So keep things about the concepts and talk about what you know. What kinds of experience do you have, and what do you think the future is going to hold? What do you want to see, and what are some trends that are developing that you aren't really impressed with, that you don't like? Comment down below, let us know. Of course, if you like this video and like this format, big thumbs up so that you can share it with your friends, and tune in next week for another episode of the Android Guy Weekly, starring me, Joe Levi.